Well, we've been working with radical expressions for a while. So let's take one. Cube root of 125. So now we have to go and start talking about something new for us. You did not have this in middle school. And we're talking about rational exponent. Rational exponents. And like, okay, so I was trying to think, what's the best way to explain this? So let me go back to variables. So you know if you have a variable, just at A, or let's say a W, we have to always remember that that A has an exponent of 1, which is assumed. Then the W has an exponent of 1, that's assumed. Okay? So we know that's there. We don't think about this much, but the same goes for numbers. So if I have 22, just think, what is actually 22 to the first power? If I have negative 5, that's just negative 5 to the first power. Because we could have negative 5 to the third power, we could have 22 to the 40th power, or whatever it is. So we don't think of it that way much. However, for what we're doing here, it's going to help. So let's remember that we have a radical expression, the cube root 125, trying to talk too fast. It's actually, officially, the cube root of 125 to the first power. To the first power. And that's going to help us because a radical expression can be translated to a rational exponent. And the equivalent of the cube root of 125 is 125 to the 1/3 power. And if you remember that there's a 1 here, that makes this a lot easier because basically the fraction, the numerator, comes from whatever exponent is, again, whether it's a number or a variable, whatever exponent is for that number or variable that is under the radicand. And then this looks kind of weird. I'm going to use a different, let's use a different color. I'm going to get there. And then in the denominator, it's whatever the root is. In this case, it's a cube root. But obviously that could be a 4th root, 5th root, it could be a square root. So it could be, any sorts of numbers. So hopefully we see that. And obviously vice versa. So if we have something such as, I learned how to do that without making all that squeaky sound. If we have something such as, let's take this. We have 64 to the 1/2. Hopefully we'll remember, it's like, okay, wait a minute, if I go back and forth, yes, let's put arrows on both sides. Because we can go back and forth. You go one way and the other way. So, okay, I take my rational exponent, okay, I make that into a radical expression. I have to figure, okay, create the one in the denominator goes up here. So the denominator goes here. It's the 2. And we know the number goes in here. And just out of practice, I would actually put the 1 there. Again, we're going to keep using different colors for it. Makes it fun doing coloring. So the 1 goes here. And that'll be helpful later when it's not always to the first power. It's to other powers. So you end up with the square root of 64, which obviously you can just write as the square root plus 64. That's 64 to the first power. Again, just have 64, we know it's to the first power. And when we're doing the square root, we don't put a 2 in there. And if we have to solve, we have to simplify. So if we have to simplify this, oh, we know what this is. Simplify. Well, square root of 64 is a perfect square. And so that's 8. So hopefully you see that. So rational exponents from one to the other. Hopefully that'll help you to understand how that works.